In this question, we've got a pole AB of length 3 meters. So let's get a pole AB of length 3 meters and weight W newtons. It says weight, so I'm not doing W times G. I would just do W. Is it a uniform? Yes, it is a uniform rod. That means in the middle, this is going to be W. Because this is 3 meters, that means this is going to be 1.5. This is going to be 1.5 as well. The pole is held in a horizontal position in equilibrium by 2 vertical ropes attached at points A and C. Okay, so this is TA, and then somewhere here, let's say, is TC. And then what do we know about TC? AC is 1.8, and that means this is 0.3. So the remaining should be 1.2. So this is the point C. A load of weight 20 newtons, it says weight, so I'm not doing 20 Gs, is attached to the rod at B. So this is 20 newtons. The pole is modeled as a uniform rod. The ropes are light, inextensible strings. We have to show that the tension in the rope attached to the pole at C. So we have to show TC is 5W over 6 plus 100 over 3. So because we have to show TC, if I resolve the forces, it doesn't really help because that would leave TA in this. So the best thing that we can do is we can take the moment about A so that TA will be eliminated. So taking moments at A, so let's just highlight the point. So this is TA. The first force that we have is W, and it is going in the anti-clockwise direction. 20 newtons, that is also going in the clockwise direction. So W times perpendicular distance is 1.5. The next force that we know is the 20 newtons force. Perpendicular distance is the entire length of the rod, which is 3 meters. So that is 20 times 3. And then both of these two moments, they are going in the clockwise direction. The only one that is going in the anti-clockwise direction is TC. So that is TC times perpendicular distance, that's 1.5, 0.3, that should be 1.8. So we can go ahead and say TC is equal to 1.5 over 1.8 W plus 20 times 3 over 1.8. Now we have to get this to 5 over 6. Now some of this is quite evident. We could cancel it off using the 3's. So that would give us 5W over 6. So that was easy. Now for this part, we can cancel off. So this becomes 0.9. That becomes 10. And then 0.9 I can again times by a 10 times by a 10. This would then become 100 times 3 over 9. So TC would then become 5W over 6, and that then becomes 100 over 3, which is part A. So what we had to remember in this question was resolving never really would have helped us, because TA would again B in the picture. We had to use the moments at A so that we can kind of eliminate TA, and then only TC would be remaining in the equation. So that is part A. However, if you look at part B, yes, now we are trying to find what is the tension at A. So we've already figured out that TC is this, so now it's better we could just resolve it. So TA plus TC, we can say resolving the forces vertically is equal to W plus 20. So TA would then be equal to W plus 20 minus TC is 5W over 6. This would then become minus 100 over 3, which can be then simplified as W over 6, 5W over 6. So you can think of this as 6W over 6, which would then become W over 6. 20, getting a common denominator, that becomes 60 over 3, and then minus 100 over 3, which then becomes minus 40 over 3. So TA would then become W over 6 minus 40 over 3. And that is part B. Part C says, given that tension in the rope attached at C is 8 times the tension in the rope attached to the pole at A. So we know that TC is 8TA. We have to find what is W. So I think, yeah, we've already figured out what is TC. Now we are not changing anything in this system. The weights are still the same, the positions are still the same, which is why I am able to use the previous values that were found in question or part A and B. So what we are going to do is we're going to use this part. So let's just erase all of this. We're just going to use this part stating TC is 8 TA. We know what is TA. TA is W over 6 minus 40 over 3. And we know what is TC. TC is 5W over 6 plus 100 over 3. And then all we have to do now is solve this system. So that gives us 5W over 6 plus 100 over 3 equals 8W over 6 minus 320 over 3. So swapping, that would give us 5W, 8W, that becomes 3W over 6. 320, 100, that becomes 420 over 3. So we can say half a W is equal to 140, W is equal to 280 newtons, and that is part C. So again, in this question, we were able to use answers from part A and B because nothing in the system was changed. No weights were added, no weights were taken off. We didn't change any positions of the beam, or yeah, all the everything was in place. So that is the reason why we were able to use the values from part A and B to get to part C.